Welcome to our NLP class. This is part 17. In this class, we are going to learn about some basic math in order to understand the PCA model. So, for the PCA model, we need to know little bit of math. So, let me go through one by one. First, we will learn about how to calculate mean and how to interpret mean, variance and covariance, and finally covariance matrix. So, this one mean, everybody knows what is mean and how to calculate mean. If I give you 3 numbers, how will you calculate the mean? There are 3 numbers 2, 4 and 6. We can calculate and find out the mean. How would I find out the mean? So, I will sum up all the x's and then divide those numbers by total count of those numbers. This is n. Is that correct? Then here for these 3 numbers, I will be adding 2, 4 and 6 divided by 3. I end up having 4. So, let me give you another 3 numbers. Those are 1, 4 and 7. What is the mean for these 4 number? 1, 4 plus 7 divided by 3, 12 by 3, mean is 4. So, now I am asking you a question that if I give you this number, so in NLP models we interpret these numbers as our feature vector that goes into our mapping function f of x. So, all xi's are the numerical vectors that goes into my f of x. If I give this 3 numbers 2, 4, 6 and ask my f of x, that's mapping function, to understand 2, 4, 6 and another 3 numbers 1, 4, 7, try to understand these 3 numbers. Just by looking at only the mean, I cannot understand the difference between these 2 set of numbers. So, I am trying to understand is these 3 numbers are same or different, are they telling the same story or not. We will plot these number on single axis, then we will see how different these numbers are. Now, I have these 3 numbers on this x plane, and again I have another 3 numbers, second set of numbers 7 and 1. Here the distance, how did I compute that mean? Just by adding these 3 number and then dividing this number by n. Just by looking at mean, I cannot differentiate these 3 the 2 set of numbers, set 1 and set 2. But there is another matrix, by using that we can understand the difference between these 2 sets, what is called as variance. So, here we want to measure the spread of this number, just not looking at the average, we want to understand the variance, how spread these 3 numbers are, 2 sets are. This is measured using how it is far from its mean. We know the mean is 4, it is actually number 6 is moved from 4 by the unit of 1, on the left direction it is 1. In the same way, if we measure the movement of 7 from 4, it is 2, and movement of 1 from 4, it is 2. Now, if we square these differences like 1 square, 1 squared, and the 4 mean is on the same number, the difference between 4 and its means is 0, then it is 0 squared, and 3 becomes 2 by 3. Again calculating the same variance for the second set of number, then I get 2 square plus 2 square plus 0 square by 3, which is 8 by 3. Now, I know this these two numbers are not same, the variance are different. Now, I can differentiate these two sets. How do I mathematically write this variance? For variance, we calculate the difference between xi and x mean and then square it for all i's. So, now I know variance. By looking at the combination of mean and variance, I can explain the input vector space. Now, if I feed these two numbers 246, 147, if f of x understands what is its mean and variance, it can differentiate these two sets. And again, this mean and variance itself are not good enough to explain the complete information. So, there is another type of information that is not explored by mean and variance. Let me give you another example. Here again there are 3 numbers, but those numbers are in xy plane. That means, those numbers, those points are described by x and y on 2 dimensional plane, x and y. Here there is a number x 0, 0 and another number which is 1, 1, second point, first point. So, let me see x 1, this is x 2, or let me call it as a 1, a 2, because I used x for the coordinates x and y. So, let me call this one as point a 1, this is a 2, this is a 1, and my a 2 is 1, 1, and I have another number a 3. What is my a 3? A 3 is minus 1 and minus 1. This is my third coordinate. So, now I have a line, I can craft that line in this xy plane, and these 3 numbers are in the same line. Again, I am just plotting 3 more numbers on the same xy plane here. My first number, let me call this as b 1, and this one is b 2, and this one is b 3. My b 1 is minus 1, 1, my b 2 is 0, 0, and b 3 is 1, minus 1. So, now how would I differentiate these 2 sets of numbers? My one set of number is a 1, a 2, a 3, 3 points, and another set of points b 1, b 2, b 3, and how would I differentiate? So, can I just use mean and variance? Let me calculate my mean. Mean is just a average of these 3 numbers. So, mean for x axis is just adding all these zero, then here on the other direction on y plane it is 1, 0, 1, minus 1 by 3, 0. This is for my set of number a 1, a 2 and a 3. Similarly, if I calculate the mean for the second set of numbers b 1, b 2, b 3, I get the same value. b 1 it is minus 1 on x plane, this is on y plane, x axis, this is on y axis. On x axis it is minus 1, 0, plus 1 by 3 which becomes 0, and again on y plane 1 0 minus 1 by 3 equal to 0. Now, the means are same, and let me calculate variance. I am calculating variance. Variance for set of points C A. Here it is the distance is 1, here the distance is 1. So, my variance would be 1 square, for the second point is 0 plus 1 square by 3, which is 2 by 3, and for the set of number B, here also the distances are same 1 and 1. So, the variance becomes 1 square 0 squared plus 1 square divided by 3, which becomes 2 by 3. Here that mean and variance index says that these three set of the three points on this plane A and B's are same. But when we plot it on xy plane, we know that these are not same. Then how do we differentiate these two sets? There is another metric which is called as covariance. Covariance. How to calculate the covariance? Just multiply x and y and then sum it up, finding out, and then later on find out the mean. Just multiply this x1 y1 and then take the average. This is what the covariance is. So, covariance can be expressed mathematically like this distance from its mean for x axis and y axis. That x I from its mean and y I from its y mean, and sum it up for all the points in the plane and then take the average. This is called as variance. When I calculate the variance, I will see what I get. Let me calculate variance for A's. For my A's, if I calculate my variance, it will be like let me go to the new page. Yeah. Here I have my numbers. This is what 1 comma 1 is minus 1 comma 1 0 0, and now I am calculating my covariance. This is x, this is y. So, all A1, A2, A3, A1, A2, A3. So, I am calculating my covariance. How do I calculate? I know its mean value is 0, then I just multiply its this covariance formula is xi from its mean and yi from its mean divided by 3. Now, for all these three numbers I get it is minus 1 which is multiplied by 1 plus 0 multiplied by 0 plus 1 multiplied by 1 and divided by 3. What I get? This is minus 1 1 minus 1. So, it will become 1 plus 1 by 3 which is equal to 2 by 3. This is my covariance. Again let me calculate covariance for points B1, B2 and B3. What is my B1? Minus 1 comma 1, this is 0 0, and my B3 is 1 comma minus 1. So, covariance for B's are again calculating this for all the i's, B i's from its B mean, and then here this Psi and B are in x and y axis. So, instead of saying Bi's, I use the same formula, and then calculate covariance for the set of points within the set B. Now, I get minus 1, which is multiplied by 1, and 0 multiplied by 0 plus 1 multiplied by minus 1 by 3. Here I get minus 1, 0 minus 1 by 3. Now, my covariance is negative direction, which is minus 2 by 3, but originally for a set of points A, it is 2 by 3. Now, I know that the three that points are not same, that A's and B's are not same. So, with the help of the covariance, we can measure the direction of change. So, these points, this is a positive direction, 2 by 3 is positive number, which says that all the points in this yellow line are actually changing in positive direction. When x increases, y is also getting increased. It is a kind of positive slope. And when I look at the points on B, which is in opposite direction, when the value gets increased and when the value of y get increased, the value of x gets decreased here. And on the other side, here when x gets increased and y gets decreased. So, that these two factors x and y are negatively correlated for B's. So, it actually gives a direction in which these two axes are correlated. X and y are negatively correlated for B's, and for A, x and y's are positively correlated. So, we get more information by using the index covariance. So, just by using our mean, variance and then covariance, we understand, we can learn about the set of numbers that are set of input vectors. In our NLP model, this we need to understand what this xi's represents. Now, we just looked at x and y, which is in 2D plane. What happens when we have numbers in multiple dimension? We may have that input vector just varies from x1 to x5, which is 5 dimension. Then how would I understand the difference between each vector x1, x2, x3, x4 and up to x5? So, then we can expand this calculation, covariance calculation, for all the dimensions in the input space I equal to 1 to 1 to up to 5, just by using our covariance matrix, which is defined as, usually just defined as sigma. So, the formula for the covariance matrix is just understand our x's and then calculate the covariance. X in our, we do have 5 variables or 5 features in the input space, and we can calculate covariance between these features. This measures how each feature is related to another features in this complete vector. What is the relationship between x1 and x1, which is measured by variance of x1, and what is the relationship between x1 and x2, that the correlation between x and x2, direction of relationship, which is calculated by covariance between x1 and x2. Then next one is my x3, which is calculated by covariance between x1 and x3. Then here is my x4, which is calculated by covariance between x1 and x5, and here it is my x5, which is measured by covariance between x1 and x5. Similarly, we can repeat this exercise. So, here I will be calculating covariance between x2 and x1. Here it is x2 between, so it becomes variance of x2, then covariance between x2 and x3, covariance between x2, x4. I will repeat this and I quickly write all those, which is covariance between x3, x1, x2, x3, variance between x3 and x3, like this. Finally, covariance between x5, x1, we end up in having variance of x5. So, when you look at this covariance matrix, what do you see is, it is the diagonals are variance, and we know it is a symmetrical matrix. The values above this diagonal are equivalent to the below the diagonal. Here what I see here is covariance between x1 and x2, here it is covariance between x2 and x1, they are same, measuring the variance between x1 and x2. So, these are same, it is a diagonal matrix. So, now in this class we learned about mean, variance and covariance matrix, and how we can use these metrics in our NLP models. In our next class, we will see two more calculation, two more formulas, which is very important for this PCA model, which is called as eigenvalue and eigenvectors. We will learn about these two fundamental formula in our next class. Till then, bye. Thank you.